All right, 1.5. Let's talk about what's in 1.5 and 1.6. So one of the first things they talk about is measuring an angle. What's weird about make sure this works. Why is this not working? Now it is. Okay. Oh, that drives me crazy. Why is it doing that? Okay. So, with a ruler, you know how the ruler, you can start it at 0 and just line it up to, line whatever you're measuring up so that you can measure how long it is, right? Well, we try to do that with angles too, but you'll notice there's actually two scales on this. See how here it's going from 0 to 180 going this way, and here it's going from 0 to 180 going that way. It's like if the ruler had also 0 here and 2 over here, we'd still have the same length, right? And it'd still be 2. It's just we would say, okay, it's starting at 0, we go to 2. It's not 0 length just because there's a 0 here. Because we started here and went this way, it's 2. So like this angle right here, see how it's starting with 0 here? I would use this scale down here and I would call this one 35 degrees. Right? See how it goes from 0, it's halfway in between 30 and 40, it's at 35. Now, if I wanted to measure this angle, if I wanted to measure this angle right here, one thing I could do is I could say, well, this whole thing from here to here, in other words, angle AOC, its measure is 65. So if this whole thing is 65 and that's 35, well, this must be 30. Now, I could also get that by subtracting 35 minus 65. But the idea is if the whole thing is 65 and this is 35, that part's got to be 30. So you'll notice, now this was something on for the worksheets to practice for the test. That had already gone over how to name angles, but notice they're in the book, they're only introducing it now. AOB is this one's AOB, right? This is AOC. AOC is 65 degrees. See that one's 65. BOC, that one was 30. BOE, you're going, so notice here, if it was BOE, you're going from, this measure here is 30, at B you're at 35. And E is at 145, right? Because it's in between 140 and 150. I just subtract. That would come out to 110. That's what BOE is. 110. Oh, that looks so terrible. Sorry about that. There, let's try it again. It looks like it says no. Oh, all right. What's the next page here? Don't know about that. Okay. Next page. Come on. Oh, I know I won't do that because there we go. Okay, we talked about naming angles. This angle right here, we could call it CAB or BAC. Either of those. Since there's no other angle with A as a vertex, you can just call it A. But also they have a little number here, you can call it 1. So there's 4 different names for this angle. CAB, BAC, angle 1, or angle A. Now, the angle here for the lighthouse, we can't call it angle M because there's three angles here, right? There's this angle. I wrote a 1 in here. We could call it angle 1. There's angle 2, which is from here to here, KML or LMK. There's also a third angle here. There's all of this together, which we could call angle 3, or we could call JML or LMJ. Any of those work. Notice this one and this one you'd have 4 names for because they also have the number in there. Here there'd only be 3. PQR or RQP or Q. Come on. Now, the protractor postulate is like the ruler postulate. It's saying that there's a measure, and there's only one measure. If you have an angle, you can give it a unique number. It's not like the temperature outside, which is different on any given day. The measure of the angle is what it is. And as long as this angle doesn't change, the measure of the angle won't change. Now they have vocabulary, and this is important for us to deal with here. Acute angles, less than 90 degrees. Right angle, exactly 90 degrees. Obtuse, greater. And a straight angle is exactly 180. It doesn't even look like an angle, right? It's just a straight line. But we call it a straight angle because it's kind of naturally what happens. If you open this thing up all the way, you get to a straight angle. I like to think, when I hear acute, I think acute little angle because it's small. Obtuse sounds like obese because it's like a fat angle. So acute little angle, obese, obtuse. Straight angle, like a straight line, and a right angle is the right way to build. When they build buildings, they generally use right angles. Okay, don't worry about the construction stuff that's in there. We're doing with the construction stuff a different way. Up here we had, okay, we're not worried about that. Identifying congruent angles. So congruent angles means they have the same measure. So see the little marks here? You'll recognize that from the practice problems for the test. When they have the same marks, it means they're congruent. So G and B are congruent angles, and F and D are congruent angles. And so if this angle has a degree, they said it was 140, or actually they said this one was 140. If this one's 140, this one has to be 140 because they're congruent. Okay, all right, one last idea here. The angle addition postulate. Again, it's a postulate, we can't prove it, but it basically is saying that if you have two angles that are next to each other like this, they say P is inside this angle, inside RST. It means that this angle plus that measure of this angle plus the measure of this angle has to equal the measure of the whole thing. That's very similar to remember the segment addition postulate that said if I had A, B, C, that AB plus BC had to equal AC because it's a straight line, it only makes sense. Same thing here except for their angles. So this angle, and this angle have to equal this angle. Measure of angle 1 plus the measure, oh, that looks so terrible. Hold on a second, let me stop being lazy. measure angle 2 equals measure of angle 3 in this drawing here. They used the way of naming it with the points, but it's the same thing. Okay, so with that, we can then write equations the same way we wrote equations here when I gave you, this one was x plus 3 and this was x plus 4 and the whole thing was 17. We wrote an equation, right? Same deal here. See how they said 2x plus 10 was this measure, 4x minus 3 was this measure, and they said the LKN, that's the whole thing. They said the whole thing was 145. So that's how they wrote their equation. 145 equals the two things added together. They solve for x. Okay, whoop. Here, notice that because this is a straight line, we know these two add up to 180. If they tell you it's a straight angle, that means these two add up to 180. Because they told you that this was a right angle, it means that these two add up to 90. If they tell you, here it says, using a bisector to find angle measures. If this is a bisector, that means it cuts it exactly in half. So that means if this is 24, that makes this have to be 24. And it means the whole thing has to be 48. That's what they took a long time to say it, but that's what they're saying. Okay, that was the bottom of that. Got that. Come on. Okay. All right. Now, that is all the vocabulary and stuff for 1.5. Let me